Hello everyone, welcome to this math video where we have many parts to it. So let's approach the part A first. Part A, we are supposed to express 240 and 2750 as a product of their prime factors. Index notation. Okay, so for part A, 240 will be equals to 2 to the power of 4 times 3 times 5. And for 2740, 50, this will be equals to 2 times 5 power 3 times 11. Part B require us to find the largest integer, which is a factor, and therefore this one we are actually looking at the highest common factor for 240 and 2750. So for this particular question, if I were to list this out quickly, then we just need to find the HCF. In this case, 2 is the common between the 240 and 2750, and 5. Yep, these are the common factors. And therefore, HCF will be equals to 10. For part C, notice we are trying to find the smallest integer, out of which 240k is a multiple of 2750. Okay, the smallest already tell us that it's supposed to be a lowest multiple, and because of the fact that this number 240k has a factor 240 inside it, it is also a multiple of 240, and therefore we are actually looking at LCM. This LCM is actually 240 and 2750. So the first step right for part C that will help us a lot is therefore to be able to first find the lowest common multiple of these two numbers first. That will help us a lot. And from here, we need to find all the factors of the two numbers. And this will give me a value of 66,000. And from the definition just now, we also know that this LCM is actually the 240 times this k. And we have found out that this LCM is equals to 66,000. So how do I find k? 240 times k equals 66,000. Yes, we just need to divide by 240. And we will be able to get 275 as my answer for K. Moving on to part D. They tell me that for part D, first, this is a square root. And after I square root, it's a whole number, right? This tells me something, you know. So for part D, right, this tells me a very important thing. This tells me that when I square root this 240m, this is actually a perfect square. Meaning that, or, and this in turn tells me that the powers of its prime, powers or index, okay, factors has to be able to be divided by 2. Is divisible by 2. So I just need to make sure that. So you can see that in my working, I would actually express 240m as 240 I already know is 2 to the power of 4 times 3 and times 5. And of course there is still this m here, this number here, which I'm also going to multiply by that. And I observe all their powers. And I saw that 2 already have 4. 3. Actually there's only 1, huh? 5 also only have 1. But the whole thing, all the powers must be able to be divisible by 2. So this means that I need another 3. From where? From m. That means this m, I need another 3. So that 3 times 3 equals to 3 power 2. I will also need another 5 from m, such that 5 times 5 equals to 5 power 2. And the power 2 can be divided by 2. Therefore, just by pure observation, m must be 3 times 5, 15. And for part E, the last question here. We have a cube root, and it is again a whole number, so using the same idea from part D, part E, instead of square root, it is a cube root. And they say it's a whole number, it means that it is a perfect cube number, which would then tell me that the powers or index of its prime factors must be divisible by 3. So I'm going to now again express 2750n in all the prime factors. First for 2750, which will be 2 power 3, 2 times 5 power 3 times 11 times this special just wear the same color, this n. So I must times n, okay? Now, I'm going to start observing the powers now. 2 actually currently has 2 power 1. I need how many more such that I can divide by 3? Yes, I need another 2 more, and these 2 more must come from somewhere. So that these 2 more must come from the end. So that 2 power 1 times 2 power 2, we have 2 power 3. Right? 3, 5 already have power 3. 3 can divide by 3. We don't do anything to it. 11, currently we only have 1. So we need how many more? Yes, we need another 2 more of the 11. And they must come from somewhere. They come from where? They come from the end. So by pure observation, n is therefore 2 power 2 times 11 power 2. And that will give me a value of 484. And we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.